Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over equation stoichiometry with the focus on mass-to-mass conversions. So let's get into this. So the first thing I want to point out is the roadmap that you should know. This is the roadmap, right? So basically in a stoichiometry problem, you're going to be given the unit of some substance and you're going to be asked to convert to a unit of a different substance in the balanced equation. So you have a balanced equation. That's why it's called stoichiometry. It's not called stoichiometry unless you have a balanced equation from which you are going to be using conversion factors, mole ratios to convert from one substance in the equation to a different substance in the equation. So you're going to be given some unit of that substance. It could be grams, it could be micrograms, it could be liters, it could be whatever the case may be. So you're given that unit. Now, the key here, this is really important to remember when you're trying to remember the strategy to use. When you're doing stoichiometry, you've got to get to moles. Your goal is to convert whatever they give you, your goal is to convert that to moles if possible. It should be possible to do that. So whatever they give you, you convert that substance to moles. As soon as you convert to moles, you can now use the mole ratio in your balanced equation with the coefficients, right? And then you could use that to convert from the moles of the substance you're given to the desired substance that you want. From there, once you get moles, your then goal is to convert from moles to whatever unit they're asking for. If they're asking for moles, then you're done. If they're asking for grams, then you got to convert that moles to grams. If they're asking for micrograms, then you got to convert your moles to grams and then grams to micrograms. If they want you to convert to liters or milliliters, then you're going to have to convert your moles to liters using molarity. If you know how to do that. If you don't, go see my video on how to use molarity as a conversion factor, but you get the gist. So this is your roadmap. This is your roadmap to go from one substance to the other substance when you're using a balanced equation. So you're given the unit of some substance. We're going to assume that this is some sort of mass they're giving you. If they give you some sort of mass that is not grams, then you got to convert it to grams first. Why? Because the goal is to get to moles. And if you don't have grams, then you can't use molar mass as a conversion factor. So if they give you some unit other than grams, you got to use a conversion factor or maybe a few conversion factors to get it from that unit in mass to the unit in grams that you want of that substance, whatever that substance number one is. Okay. Once you've got grams of that first substance, then you're going to use the molar mass of that substance to convert from grams to moles of that one substance. Once you've got it into moles, then you can use the mole ratio between the substance that you have and the substance you want in your chemical equation. And you're going to use the coefficients for the mole ratio. So you use that to convert from moles of substance 1 to moles of substance 2. And then once you're here, you're converting to whatever unit that you need. If you need a mass unit again, then you're going to have to convert the moles of substance 2 back to grams using the molar mass of substance 2. And then from there, you're going to use whatever conversion factor or conversion factors, plural, to get to the desired unit that you want of substance 2. And that's it. This is pretty much the roadmap that you're going to use for many stoichiometry problems. And I'll even say this. So the main highway is going to be this one right here, converting grams to grams, right? Because when you got grams, you can convert that to whatever desired unit you want. It depends on the problem. But this is by and large, if it's a mass to mass conversion, this is going to be the main highway. Once you got grams or starting with grams, then you're on the main highway. If you're not giving grams, then you're off the main highway. You're on a side road and you got to get on the main highway. So that's what this is. You're converting whatever unit you're given to grams. Now you're on the main highway. You go through whatever you need to go through, right? So you're going through your steps or your destinations on the highway, on your road to wherever you're going, right? If I'm going to push the analogy of a road map, right? So you're going through your destinations on the main highway, and then here, if you're at grams, if they're asking for grams, you're done. You've reached your destination. If you if they're not asking for grams, if they want something like I said, beyond grams or micrograms, megagrams, whatever, then you've got to do some extra conversion factors. Maybe they convert to pounds. I don't know. So it just depends. So if they want something other than grams, then you're going off the main highway to do that. Okay, that's my spiel about the roadmap. Let's apply this to a problem, a practice problem. So over here, I have this balanced equation. I have aluminum sulfate reacting with sodium hydroxide to produce aluminum hydroxide solid and sodium sulfate. Okay, so the question is, if 0.655 mg, this is not magnesium. Mg here does not stand for magnesium, it stands for megagrams. Capital M is the prefix abbreviation for mega. So here I'm given 0.655 megagrams of aluminum sulfate. And they're saying this is added to water, then the question is, what is the maximum mass of aluminum hydroxide that can form from this amount of aluminum sulfate? Okay, so now first, before we get in, this word maximum, don't get hung up on the word maximum or minimum or anything like that. Just read it as like, say, what is the mass that is produced of this substance from this amount of substance given, assuming that it reacts completely and we don't lose anything, it's 100% efficient and all that stuff. Okay, so first thing you're going to do is we're going to start with what we're given. We're going to write a conversion. We're going to write a conversion factors to convert. So we're given 0.655 megagrams of the aluminum sulfate, okay, over 1. And notice here, when I write my conversion factors, I write 3 things. I write the number, the unit, and the substance formula, or maybe the substance name if I abbreviate it, but I am identifying those 3 things. It is important in stoichiometry that you are identifying the substance that you are using or that you're converting or that you're referring to. Because remember, we're converting from one substance to another. If you don't write down the substance that you are referring to, then it's very easy to accidentally flip a conversion or make a mistake that could be easily avoided if you write down the substance. So please write down the substance along with the unit and the number that they give you. Okay, so now roadmap, right? So they gave me a unit, it's megagrams. So I need to get the grams, so I'm going to have to use the metric conversion between megagrams and grams to convert. So I'm going to multiply by the conversion factor. So what's the relationship between megagrams and grams? Well, mega means 10 to the 6, a million. So 1 megagram is equal to 1,000,000 grams. So since I have megagrams here, I'm going to put 1 megagram of Al2SO4 on the bottom and 10 to the 6 grams of Al2SO4 on top. So megagrams of this substance cancels out. Now I have grams. Now I'm on the main highway. So now I'm going to go from grams to moles to grams. Oops. Butterfingers. Okay, so I need to use the molar mass of substance 1 to do this. So I look up, I calculate the molar mass of substance 1, and the molar mass is 342,154. So I'm going to continue. Do I have room? No, I'm going to continue down here. So The next thing I'm going to convert by is the molar mass. So I'm going to put that here. So since I have grams on top, I'm going to have grams on the bottom. What did I calculate? 342.154. So 342.154 grams is the molar mass. That's the mass of 1 mole. And this is going to be Al2SO4 3. And then that's equal to 1 mole. That's supposed to be Al. So Al2SO4 3. So now the grams cancels out. Now I have moles. Now I can use the mole ratio in my equation. So that's the next step. Moles of substance to moles of substance 1 to 2. I'm going to use the mole ratio. I want to get to aluminum hydroxide. That's what they're asking about, aluminum hydroxide. So what's the mole ratio between this substance and this substance? 1 mole of this produces 2 moles of that. So it's 1 to 2. So I'm going to set up my conversion. So I have moles of aluminum sulfate on top. So I'm going to put the moles of aluminum sulfate on the bottom. That's 1 mole. So 1 mole of Al2SO4 3. And then it's going to be 2 moles of the aluminum hydroxide. So there's going to be 2 moles of AlOH3. And so moles of aluminum sulfate cancel out. Now I have, getting mixed up here. So I have moles of aluminum hydroxide. So now I'm here. I got moles of my substance 2. Next step is to get grams of substance 2, again, using the molar mass of substance 2. Because remember, molar mass allows us to convert between moles and grams. So what's the molar mass? You got to calculate that. So when you calculate it, you come up with 78.0035. 78.03. Okay. So 1 mole. So I'm going to put 1 mole of aluminum hydroxide. So 1 mole of AlOH3 on the bottom. How many grams is 1 mole? 78.0035. So 78.0035 grams of the AlOH3. So moles of aluminum hydroxide cancel out. Now I have grams of aluminum hydroxide. Oops, let me fix this. There we go. So now I have grams of aluminum hydroxide. I am right here on my roadmap. So, but they're not really asking us for grams. Notice they don't really say what is the maximum mass. Since they're giving us megagrams, it makes sense to convert that to megagrams for our substance 2. Otherwise, we'll have a very large number of grams. So let us continue. So we're going to do our last conversion here. So we need to convert grams to megagrams. So we're going to use the same relationship here, but we're going to have to flip it because notice here we have grams on top. We're going to have to put grams on the bottom. So again, 1 megagram is equal to 1,000,000 or 10 to the 6 grams. So 10 to the 6 grams goes on the bottom. So 10 to the 6 grams of what? Aluminum hydroxide, OH3. And then on the top, we have 1 megagram, again, of aluminum hydroxide. So here, grams of aluminum hydroxide cancel here, grams of aluminum hydroxide. And now we have megagrams of aluminum hydroxide on the top. That is what we want. So we're done. No more conversion factors. So all we need to do is calculate the number on our calculator. So all I have to do is multiply by everything on the top and divide by everything on the bottom. And then my calculator will spit out the rest. And when you do that, you get this mass. You get 0.299 megagrams of aluminum hydroxide form. So that is the maximum mass that can form from this amount of megagrams of aluminum sulfate. Now, for those of you who are interested in sig figs, why did I write 3 sig figs here? So if you look at your measurements here, remember any conversion factor that's exact, you ignore. So the 1 to 10 to the 6, 1 megagram to 10 to the 6 grams, that is metric to metric mass. That is exact. We can ignore. Same thing here. We can ignore this. Now for the molar mass, that is a measure. So this is six figs. Here we have six figs here. And then what else do we have? Oh, the 2 to 1 ratio. The mole ratio is exact because we're counting the number of moles that are related to each other. So 1 mole of this to 2 moles of this, 6 moles of this to 3 moles of this, and so on. That's a counting number that's exact. So we can ignore that. The only other measurement is the one they gave us, 0.655. And so if we're going to compare the number of sig figs, remember, the rule is for multiplication and division is that the answer should have the same number of sig figs as the least number of sig figs in your measurements that you're multiplying and dividing. So here we have 3, here we have 6. Well, the lowest number is 3. So 3 is the number of sig figs you should have. So you round your answer on your calculator to 3 sig figs. And there you have it, folks. That is the answer to the question. That is it for this video. I hope you enjoyed the video. If this helped you in any way to do your mass to mass conversions, then please like the video, share the video, hit that like button. Also, subscribe to my channel, please. And when you do, make sure you click on the notification bell and click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem that you want me to go over or a question you want me to answer, or maybe you have a topic you want me to cover in another video, then please, by all means, let me know. I would love to do that for you. Thanks for joining me and have a great day.